We're going to graph r equals 3 sine 2 theta, and based on the equation, I know that this is a rows using the common polar equations in their graphs table in the text, where a is 3 and n is 2. And since n is even, there is 2 times n number of petals. I can also determine where the petals begin and their petal spacing based on the information that's given in that chart. But let's first start off with symmetry. Let's see where our symmetry is. When I substitute in negative theta, remember that sine is an odd function, and so this is going to be r equals negative 3 sine 2 theta, which is different, so this is inconclusive. Now we're testing symmetry about the line theta equals pi over 2, where we substitute in pi minus theta into the equation. So we have r equals 3 sine 2 pi minus theta here. And in this case, it is the sine of 2 pi minus theta. And so that 2 actually gets distributed. And we have 3 sine of 2 pi minus 2 theta. Let's use the sine difference formula to determine what the sine of 2 pi minus 2 theta is. This gives us sine 2 pi cosine 2 theta minus cosine 2 pi sine 2 theta. And remember, we don't know what the sine or cosine of 2 theta is, but we can evaluate the sine of 2 pi and cosine of 2 pi based on the unit circle. We then have that the sine of 2 pi minus 2 theta is equal to the sine at 2 pi is 0, and the cosine at 2 pi is 1. Then we have the sine of 2 pi minus 2 theta is equal to negative sine 2 theta, which means in our equation we have r equals 3 negative sine 2 theta, or r equals negative 3 sine 2 theta, which is different and also inconclusive. Dividing both sides by a negative 1 here, when we substitute in negative r theta, we get r equals negative 3 sine 2 theta, which is different and also inconclusive. Unfortunately, the symmetry doesn't help us here. But I do know that a rose has certain attributes. I can determine the number of petals, I can determine where the petals start, and I can determine the spacing based on some information that was given in the lesson. So let's write that information down and determine kind of some parameters for this graph. Because our n value is even, so this is as if we had r equals a sine n theta, so a is 3 and n is 2, and because n is even, there is 2n petals, which means we have 2 times 2, or 4 petals for our rose. In addition, I can determine where the petals start by solving the absolute value of a equals a sine n theta, or 3 absolute value equals 3 sine 2 theta, or 1 equals sine 2 theta. So when does sine equal 1 on the unit circle? That happens at pi over 2. Then 2x equals pi over 2, or x is pi over 4 when you're solving. That's our starting point. In addition, I can determine the petal spacing by taking 2 pi divided by the number of petals, or pi over 2. So it's spaced at every 90 degrees, which makes sense because we have 4 petals. Let's graph some points to determine some R values to sketch out and then use information about roses to help us complete this graph. 2 theta would be 0, pi over 3, because 2 over 1 times pi over 6 reduces to pi over 3. 2 times pi over 4 becomes pi over 2. 2 times pi over 3 is 2 pi over 3. And 2 times pi over 2 is just pi. Using the unit circle to find the sign of those, the sign of 0 is 0, The sine of pi over 3 is root 3 over 2. The sine of pi over 2 is 1. The sine of 2 pi over 3 is root 3 over 2. And the sine of pi is 0. Approximating r, we get 0 for when theta equals 0 and pi over 2. When theta equals pi over 6, we get 3 times root 3 over 2 is about 2.6. 3 times 1 is 3, and then this is also 2.6. So at theta equals 0, r is 0. At theta equals pi over 2, r is 0. So that means that our petal is in between, it's in the first quadrant. At pi over 4, we have a distance of 3. At pi over 3, we have 2.6. And at pi over 6, we have 2.6. And this is our petal. And our petals are spaced every pi over 2, which means that I can duplicate this in each of the quadrants. At each of the pi over 4 intervals, I'm then going to mark a distance of 3. And next to each of those lines at 5 pi over 6 and 2 pi over 3, I'm going to do 2.6 just to give me some guidance to make my petals. And that is my rose. The A value of 3 being my maximum distance here. And then starting, my rose petal started at pi over 4. That's this one right here. And then it was spaced at every pi over 2 interval. Okay, I'm strictly going to use my graphs of common polar equations to determine information about the graph r squared equals 25 cosine 2 theta. Looking at my charts, I've got lines, circles, and graphs, limaçons, roses, and lemniscates. And this is a lemniscate because it's of the form r squared equals 25 cosine 2 theta. In this case, this means that a is 5. And because it's of the form cosine 2 theta, it is a figure 8 that runs horizontally. It has symmetry to the polar axis, whereas a sine has symmetry to the line theta equals pi over 4. The maximum value of 5 happens when my cosine is going to give me a value of 1. Using the unit circle, we see that the cosine is 1 when theta equals 0. So for 2 theta equal to 0 plus 2n pi, that's our general solution. Dividing everything by 2, we see that theta equals 0 plus n pi, which means that every time theta is 0 plus n pi, cosine of 2 theta is going to be equal to 1. If n equals 0, then theta equals 0. If n equals 1, then 0 plus pi is pi. If n equals 2, we have 2 pi, which is outside our interval. So cosine of 2 theta happens when theta equals 0 and pi. That's when we're going to get our maximum values. The graph is at the pole when r equals 0. So if r squared equals 25 cosine 2 theta, then r equals plus or minus the square root of 25 cosine 2 theta. So when does that equal 0? That's 0 equals plus or minus the square root of 25 cosine 2 theta. And I'm really trying to figure out when the cosine of 2 theta equals 0 now. The only time that this is going to become 0 is when the cosine of 2 theta equals 0. So just like I solved cosine of 2 theta equals 1, I want to solve the cosine of 2 theta equals 0. Cosine is 0 at pi over 2 and 3 pi over 2. I want to write the general solution because it's a double angle just to make sure I have all of the values within the interval from 0 to 2 pi. So I'm going to divide everything by 2. This means that theta equals pi over 4 plus n pi, and theta equals 3 pi over 4 plus n pi. If n equals 0, for the first one, we have theta equals pi over 4 plus 0, which is pi over 4. 3 pi over 4 plus 0, which is 3 pi over 4. But what about if n equals 1? That's pi over 4 plus pi, which is 5 pi over 4, and 3 pi over 4 plus pi, or 7 pi over 4. That means that the graph is at the pole when theta equals pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Using all of the information that we have now to graph, remember that the maximum happens at 0 and pi. So at 0, I have a maximum of 5. 5 circles out. And at pi, 5 circles out. I've got my maximum value. Now the graph is at the pole when theta equals pi over 4, when theta equals 3 pi over 4, when theta equals 5 pi over 4, and when theta equals 7 pi over 4. So I'm going in at those values. I then need to find a couple of values between those zeros. 2 theta means we're really dealing with pi over 3 on the unit circle and 2 pi over 3. Then the cosine of 2 theta is the cosine of pi over 3, which is 1/2, and the cosine of 2 pi over 3, which is negative 1/2. Now remember, r squared is equal to 25 times the cosine of 2 theta, and r is equal to plus or minus the square root of 25 cosine of 2 theta. So in my calculator, I'm going to calculate the square root of 25 cosine of 1/2, both positive and negative. This is going to be plus or minus 3.5. When I'm dealing with the 2 pi over 3, though, r squared can't be negative. The equation doesn't have a solution in this interval here. So let me graph pi over 6 and 3.5. I also know that 11 pi over 6, my graph is 3.5 because there is symmetry with respect to the polar axis. And because this is a figure 8, it's also true on the other side. So at 5 pi over 6, I'm at 3.5. At 7 pi over 6, I'm at 3.5 as well. And I can connect my figure. And that is my graph. Finishing up this section, r equals 0.8 theta, I'm going to use my common polar equations of their graph chart to identify what type of graph this is. This matches a graph that is a spiral, r equals a theta. Because it is a spiral, it's not symmetric to any of the polar axis, the pole, or the line theta equals pi over 2. The value of the absolute value of r increases for value of theta increasing and has no upper bound because it's a spiral. It keeps getting bigger and bigger and bigger. And the graph is only at the pole when theta equals 0. Because there are several revolutions of this graph, we are going to take values larger than we normally would. So let's say we go from 0 up to 4 pi and see what happens. We don't have a trigonometric function to use at this point. We're just taking 0.8 times that value. So 0.8 times 0 is 0. And I'm going to round, so I'm going to approximate pi when I'm doing this. At theta equals 0, r is 0. At theta equals pi over 2, r is about 1.3. At theta equals pi, r is 2.5. At theta equals 3 pi over 2, r is 3.8. At theta equals 2 pi, r is 5.0. At theta equals 5 pi over 2, r is 6.3. At theta equals 3 pi, r is 7.5. At theta equals 7 pi over 2, r is about 8.8. At theta equals 4 pi, r is about 10. And all I'm doing is taking 0.8 times the pi option in my calculator and approximating. Let's graph these points. At pi over 2, r is 1.3. At pi, we're at 2.5. At 3 pi over 2, we're at 3.8. At 2 pi, we're at 5. At 5 pi over 2, we're at 6.3. At 3 pi, we're at 7.5. At 7 pi over 2, we're at 8.8, which is off the chart. I'm going to connect my spiral now. And there is our spiral finishing off this section.